But what what I enjoy doing is actually statistical modeling. And when I was a fee appraiser, and I would make an adjustment, and I would sit there and pull out of the magic air, if I could find comparable sales, that I could do a sales comparison analysis. But a lot of times you got to sit there and say, well, that half bathroom's $10,000. But with statistics, I can go in and sit there and say, well, actually, it's not just $10,000, it's $8,750, because I can pull that from the market. And that's one thing that drew me to statistics. And but I also wanted to tell you some good news. And my good news is I passed the CAE comprehensive exam. So thank you. So yeah, my application goes up to vote in a week. So that was a long, long road. So we got just some simple things. Right now, there's an issue that we're talking about equity. How do we sit there and tell people that we're being equitable in what we do? And so we have to, first thing to do is define what equity is. What standards help ensure that we have equity? How do we visualize it? Then we've got emerging technologies and analytical techniques that we can use to better show what equity is. So this happens to be the September magazine for Fair and Equitable. So the first thing we have to ask is that just a buzz phrase, or does it mean anything? Why do we care if we're fair and equitable in the execution of our work? Anybody?
It means everything.
Means everything. Because how would you feel if your neighbor is paying less than you? Or even worse, how would you feel if your neighbor is paying more than you? So that's the question is, we as assessing officers have the mandate to be fair and equitable. So if we go to Merriam-Webster and we talk about what is equity, and this is just straight from the dictionary, is equity is justice according to the natural law or right specifically, I haven't had enough coffee this morning, freedom from bias or favoritism, and also fair is marked by impartiality and honest, free from self-interest, prejudice, and favoritism. So notice favoritism comes up twice in those definitions. Now, do we need to use standards?
Yes.
I mean, do we have to use standards is the question.
We used to have, we're supposed to.
Yeah. So let's say that you hired me as a reappraisal firm and I've got a magic wand. And that magic wand will wave in the air and it'll tell me exactly what the market value for any house is. Does that work?
No.
No, because that's way too subjective. So the first, really the base level that we can look at is use path. And it's uniform standards and professional appraisal practice. And this is actually the current edition. It's going to be going to 24, 25 at the end of the year. And so Standards 5 and Standard 6 deal specifically with mass appraisals. How do you develop them? How do you report it? Also, because of what we do, we would fall under judicial exception. And the reason why we would fall under judicial exception is normally as an appraiser, I cannot have bias. But as part of your your mandate of your office is you have to treat all people fairly that own property. So that puts a cloud in there. And so you would sit there and quote in judicial exception. And also there's the advisory opinion 32, which talks about specifically ad valorem tax appraisals and how to do mass appraisals for tax purposes. Now, the ones that I'm really know is the IAAO standards, which is the standard on ratio studies and the study on mass appraisal. And that's April 2013 and July 2017 are the latest versions. So, don't be afraid. But I pulled this table right out of the ratio standards because it breaks down exactly what we're looking at. So we have a COD range from 5 all the way up to, from 20 to 30, depending on what type of property. Now in the state, what is our maximum? 20. So our maximum is 20. The state says 20, you're going to follow the state saying 20. But this is their suggestions. Now underneath here, which is a little small to see, but we're going to talk about is there is the price-related bias, the price-related differential, and also we're talking about is how we go ahead and look at that for equity. So COD is horizontal equity. And horizontal equity is equals. So we're sitting there saying that if your neighbor and the neighbor to the left and the neighbor to the right have all the same model, you should be paying the same amount of taxes, right? It's not fair that one neighbor would pay more or pay less. That's the whole thing is we're talking about equals. Vertical equity, which is talking about the price-related bias and the price-related differential, is what's called vertical equity. So it's in equals. So we're talking about the upper part of the market versus the lower part of the market. Commonly they're known as strata. Now, how we reassure that the adjustments and models that we make is, this is right out of science class, is through hypothesis testing. And these are actually the two tests that we use, but the question that we have to ask is, are we appraising everybody equally? And so either we're appraising everybody equally or we're not. And if we're not, then we're going to go ahead and make an adjustment in order to make sure that we meet that requirement, that we are treating everybody equally. So when you do statistical modeling, I'm going to check each and every single variable to make sure that they're all treated equally. So I'll do it off a bedroom count, I'll do it off a bathroom count, I'll do it off of square footage, I'll do it off of any feature, whether they have a fireplace or not, or whether they have a garage or not, to make sure when I come to a model, it meets the specifications that we had earlier, that we mentioned earlier. And this is the way that we do it.
So abatement is...
So, how do I visualize equity?
Publication.
Now, if I just was giving a presentation to a town, and I just put that up, could you say that it's equitable?
They say that it's a statutory process for relieving taxpayers
It's not bad.
of the burden of property taxes, penalty, and interest. When the law
But if you're Joe and Jane Public, would they understand if I just put a screen up there and say,
No,
oh, this is
no,
equitable?
No,
No.
You have to make a picture graph.
So, the first way that I can do it is I can sit there and go ahead and make a histogram. I can say this is what what the market looks like. Now, if you notice over here on the right-hand side, there is a couple of properties over here. If I ended up having a bump here, that would indicate a different subset of the market. And I would have to treat that different subset and do the complete analysis on that, because I have to be able to compare apples to apples. Does everyone understand what I'm talking about that? Okay. Now, this is trying to explain COD and do it in a visual way. It's kind of hard. But this is, I found, kind of the best way to do it. So I have the assessed values that are on the left-hand side, and the square footage is on the bottom. So what I'm using is gross living area. So first floor, second floor. And if you notice, is we're talking about equals. So if I go ahead and pick my neighborhood, they're going to be, let's say, at 150. My neighbors should all fall in there, right? Because if my neighbors are being assessed equally and I'm being assessed equally, they should all fall in the same area. So that's horizontal. Now, this is also a good representation of vertical equity. And what happens is, as we move along the trend line, is it follows along with this. Now, these two lines here are the 95% confidence interval lines. So when we do studies, we're going to sit there and say, we're going to do it to 95% confidence, so I'm going to be right 19 out of 20 times. It's okay to have 5% that's in variable. And if you notice that we've got a little bit that falls out and above. But if you count all those, which I did, but there happens to be 20 of them, and my sample size was originally 466, which comes under 4.5%. So I'm still okay. The other thing that will happen is this right here, this number up here, which is kind of hard to see, but that is the coefficient of determination, which is also called R squared. And that represents how much of the dependent variable, which is the sales price or the assessed price, versus the independent variable, which is, in this case, would be how much the square footage is. So it's that relationship.
So, missing for some reason.
Now, vertical equity is a little hard. And if we look at this, does it look like somebody came over and just took a shotgun and went, pow, right?
So, there's a lot of confusion.
So we've got really, looks really dispersed. Do I really have equity? So here's one, which is our ideal. And so I've got it where it goes off from each side. Now, one way that I can go ahead and make it look a little bit better is to maybe look at this data in a different way. The important thing here is if you look at the R2 is close to 0. That means that they have a relationship that is equitable.
Pretty broad discretion.
And if I go ahead and put this into a frequency distribution, so what ends up happening is if I took all those dots and put them together, instead of being all spread out, you can see that the majority are right on either side of 1. And it falls off using the bell curve. So this may be a better way of displaying that information that, hey, we're looking at that we have vertical equity, meaning that properties, let me bring it back, is that all properties are being treated fairly regardless of which strata that you are.
For interest, town members say off and choose to have interest applied to late payments.
Any questions on that so far?
We talked a little bit about R squared again. If you go back to your first slide, which showed that 57%.
57, this one
Not
here?
that one, the first one, yeah.
Yeah, so 57%.
So what does that mean in terms of language? One of the statistics that we talked about on 57% right and showing us a correlation between the two.
what happens is you're looking at about 25, 0.25 and 0.80. So if it's 0.80 or higher, it's strong.
Yeah.
If 0.25 or less, it's minimal, and anything in between is moderate.
Okay.
And so, just in this case, is that the first floor and second floor, our gross living area, has a moderate correlation when it comes to our assessed value.
Right. That makes sense. Thank you.
No problem. All right. Neighborhood adjustments. Neighborhood adjustments are typically done last, because when you look at your town or all this, you may have one section where all the houses were built primarily in the 1860s. Then you got another section that they may have been built in the 1980s. And so each one has their own construction, has different, the same quality, architectural style, amenities, that type of thing. It's nothing like living in a bedroom, a house with 5 bedrooms and only 1 bath. That's the difference where you compare to something that is, 3 bedrooms and 2 baths, or 2.5 baths. Also, consumer preferences and effective purchasing power come into effect. So we're talking about the ability to buy will affect what neighborhood you can get into. Then neighborhood adjustments tend to be last, as I mentioned before, which is to avoid double dipping on a variable. So I don't want to make an adjustment, then turn around and make another adjustment that would affect that same variable. So we're having the discussion on equity, on how different neighborhoods will go ahead and be treated. Now, if we look here, my R2 is close to 0. So they're saying that this is being, that there's great equity. And if I look in a different way, is I can go ahead and put this into a box plot. Here's my 8 neighborhoods. But if we look right here, notice that neighborhood 736 happens to be a little lower. There may be a problem there. So if I look at this and I say, well, this is a little low, I may need to look at it. How do I go ahead and determine that there may be a problem? So a lot of little type, I'm sorry. But what ends up happening is when we said that we want to have a 95% confidence interval, that means that we want the medians for each neighborhood to fall between 0.95 and 1.05. That's our range. And also, we want our confidence intervals to go ahead and bracket 1. And by doing that, it sits there in centers. And as we mentioned before, as I mentioned before, we had the price-related bias, the price-related differential, the coefficient of dispersion, and also the coefficient of variation, which were on that first slide, or actually came from here. But if we look at 736, all the metrics when it came to the median look good. When we look at the price-related bias, we're at 0.003, very close to 0. We're fine. Where price-related differential is 1.003. We're fine. Then we look at coefficient of dispersion of 6.6 and coefficient of variation of 8.0. The whole thing about that is, even though it may look like there's a problem, there's not a problem. So you have to go in and not just look at the graphics, be able to support this. Now, the final way that I'm going to do that is with hypothesis testing. Now, there's 2 types of hypothesis testing that we use for real estate markets. And the fancy term is called non-parametric, meaning that it doesn't follow the bell curve. Because what ends up happening is it is typical that we have skew to the right, because we've got a lot of properties, and then you got the really expensive properties over here. And so that's going to skew our results to the right. And since we said that we're still at 5% error, right? This readout right here, the fancy word for it is asymptotic significance. You don't have to worry about that. There's not a test. What I'm looking at is it has to be 0.05 or higher in order to say that everything is being assessed equally. Then the other way that I can look, if it wasn't, I can look at the mean ranks. And what mean ranks does is it sits there and says that how close, if there's a problem, it will let me know where it is. And I would go through the process of going ahead and making an adjustment. I know you probably went into statistics land. You never thought you'd do that, before 9 o'clock in the morning, right? It's okay. The whole important thing I wanted you to take from this is that we've got a process, and the process works. So we've got a process, and the process works. The whole reason why the IAAO has the 2 standards is because there's a lot of people that have doctorates of economics that sat down and came up with this process in order to be fair and equitable. Any questions on that? Was it too much? Too little? Too much? Drink more coffee, you'll be okay? Now, emerging technologies. So where are we going with this? Where is the next step that's going to happen in the future? There is Dr. Camilla Puntos from New York, New York. She is the head statistician for finance. And she wrote 2 papers that were published, and it was talking about the Gini coefficient. So what the Gini coefficient is, the guy was Italian, he developed it in 1912, and it was a way of looking at equity and inequity. And it's commonly used in studying economics of countries. So if we're going to compare healthcare, we could compare healthcare between 2 countries by using this kind of analytical method. And it's good for large numbers, but it doesn't have to be. It works on the principle of shares. So when you look at a society, it could be 10 people or 1 million people. It doesn't matter. Everybody gets a share. And we're talking about the relationship of that share. So the equity line here is essentially would be perfect equity. Everybody's got a share, and all the shares are the same. And in that case, the value would be 0. And perfect inequity is nobody has a share until you get to the last person, which has them all. So what we're talking about is the relationship under area A, which is equity, versus area B, which is inequity. The advantage of this kind of analysis, it can be done in Excel. It gives you 4 numbers, and the advantage is it helps to get rid of using level of appraisal in the analysis, because it goes and looks at using shares as the principal. And the nice thing about it, you get a nice graphic that you can explain. Now, this one happens to be from Esri, but there's a lot of different companies that use this, but it's Gamma. And what Gamma does is it gives you a graphical way to look at your CAMA data. So it's got GIS data right here, and then you've got your CAMA data right over here. Then it's an overlay between the two. And so I can go ahead and drill down and say, okay, in this very homogeneous neighborhood, I can say, okay, what's the price per square foot? Or I can look at sale price. Or I can look at all sorts of different variables. And the nice thing is it gives me a color code. It says here, it says, well, green's okay, yellow is and red, we've got a problem. So it's an easy way to go ahead and look at it graphically. And you can use this analysis not just in, you know, at the neighborhood level. You can actually zoom out and say that you're at a county. Okay, which areas have problems? And the advantage of that is when you have to allocate your resources, how many people can come in to do, you know, to actually have boots on the ground to go and inspect. It'll sit there and say where your hot spots are. So the condos over by the ski slope, there's a problem. So we need to send some people over and look at the condos at the ski slope. The next one is artificial neural networks, or ANN. And so this is a machine learning process. So I will go ahead and get a data set, and I will let my statistical software go ahead and assign a value to all the variables. The advantage to this one is I do not have to trim my data for multiple sales. So if I got a house that sold, you know, in the same year, normally you'd go ahead and get rid of it. In this case, you don't. You do have to be careful on which variables that you put in your model. But the advantage is if you have a California style system where you know, your assessed value is set when you buy the property and it's by the sales price, this is a way to kind of even things out. But the downside to this kind of analysis is I do not have a way to explain the valuation for something that's not in the data set. So it's the good thing about this is I can use this as a theoretical ideal to compare against. So if I come up with a model, I can run this analysis and I can compare, am I close? Now, Power BI. For some reason, it's not letting me, it's sticking to the PowerPoints but not showing the website. So, there we go. All right. So, David Cornell. Yeah, he's another IAA instructor, great guy. If you've ever taken a class from him, if you haven't, you should. I can't say enough nice stuff about it. But this here is the data for 5 towns in Virginia, surrounding Roanoke, Virginia, which happens to be the star city of the South. But what happens with this is it allows you, the public, to visually see what the data looks like. So they can go ahead and play with their own analytics. And so let's say that I want to look at single-family residences. And I can sit there and say, okay, here's all my single-family residences. Notice that here's the trend line for it. And I can go ahead and bring it to, let's say, 250,000 to 300,000. So here's my neighbors, 250,000, 300,000. It shows the data that's associated with it. And what ends up happening is from 250,000 to 300,000 is, if you notice the sales price and the living area, so this takes into account, it shows that the economy of scale. So the bigger the place is, the less per square foot. So this is something that I would expect. And the nice thing about this is it has it where it can show in a lot of different ways. Here's the map that sits there and says where everybody is spatially located. And so they can see how do they compare versus their neighbor. So this gives it, it's really got some power to it. It's very, very useful. Any questions on Power BI? And I'm more than happy to have the laptop up if you want to take a look at it and see it. So, in summary, using standards, visual outputs, emerging technologies, data-driven techniques fosters a better equity communication with the public. Also, data-driven analysis helps build trust that assessments are accurate and that all stakeholders are treated fairly and equitably. Any questions? Yes?
I've always had a difficulty describing PRB and PRD.
Okay.
The differences between those two, and or how they complement each other.
Okay, so PRD is really easy. It's the mean divided by the weighted mean. And so what the weighted mean is so if I got all my assessed values and I got all my sales prices, I total them up and then I take those sums and I divide each other. PRB is a little bit more complex of a formula. The important thing about using the PRD with in conjunction with the PRB, it gives you a better look at that vertical equity. So how are we treating the not the sames? And so when we're looking at PRB, is the range is plus or minus 0.05, and if it is plus or minus, if it falls outside of plus or minus 0.10, then we would have to say that there's a problem. We have an equity problem. And the advantage of not just putting it, the whole weight of equity on the COD, you may have a good COD, but your PRB is not.
Can you have a passing PRD and a failing PRB?
Everything's theoretically possible.
Yeah.
Greater the data set, harder than that would happen.
Right. It's more granular.
Yeah.
I guess the PRB, that's really the way of looking at it.
Yep.
I've got a hard time explaining it to clients. It is kind of difficult to comprehend. The next question I have here has to do with sales chasing. You showed Man Whitney up there at one point, and Crystal
Wallace.
Right.
Yeah, it's Man
Those are
Whitney,
really-
Crystal Wallace.
Yeah, really useful to look at sales chasing. I do monitoring and I watch revaluation companies, and they can pass all the tests fine, but they're sales chasing at the same time. And the benefit of Man Whitney and Crystal Wallace is you go in and find out if they in fact are sales
Yep.
chasing. You
Yep,
use
yep.
that as your null hypothesis, yeah. So
Yep.
maybe you can speak a little bit about that and how we can determine sales chasing.
There is actually, IWO has got a standard when it comes to sales chasing and how to go through it. And it really depends on your level of complexity.
Yeah.
But hypothesis testing is a great start because you can sit there and say, I went through, I tested all my variables, and because I tested all my variables, I'm treating everybody equitably.
Yeah. Thank you.
No problem. Anyone else? So my new favorite statistical quote is, statistics are like bikinis. What they reveal is suggestive, but what they conceal is vital. And that was from Professor Aaron Lewin.
That's over.
So, thank you so very much. I'm going to stick around. If you have any questions or anything like that, please go ahead. If you're wanting to get the continuing education credits, please sign